Hello everyone, I welcome you all to Startup Academy. This academy is exclusively for ISS and we are covering the statistics paper 3 first, which is considered as more difficult than the rest of the papers. And in that we have started sampling techniques in which in the previous lecture we started second two-phase sampling or two-state sampling. Rather than two-phase, it is two-state sampling. So in two-state sampling today we'll do estimation and we'll take some notations what are the two-state sampling in this, and we'll take the estimation and we'll start with variance, and we'll continue with that. So let us begin. First, let us say that there are some important notations. Before the notations, let me tell you that yesterday we did the outline. First one, there is population. Population consists of N and M units, NM units, in which there are N clusters, each having M units, right? And then from here, with simple random sampling, without replacement, we go on to stage 1, where we select N clusters, small n clusters, and each having M units. So the total number of units are N into small m. So small n clusters, each having capital M units. This was stage 1. And from these clusters, we'll apply again simple random sampling without replacement. And we come to stage 2, which says that we have NM units, where there are N clusters, each having M units. That is taken for the study. This we did in the previous lecture. I am again writing it so that you will not be confused with the notations. So coming back to the notation, first one is Yij, capital Yij. This is the jth unit in ith cluster in the population. Second one is we'll write the population mean, which is y bar, which is nothing but 1 upon n into 1 upon capital M. Summation I goes from 1 to n. Summation j goes from 1 to m. Y I j. Where I for all, I goes from 1 to n and j goes from 1 to capital M. This can also be written as 1 upon m summation j goes from 1 to m y bar I dot, where y bar I dot is nothing but 1 upon n into summation I goes from 1 to n y I j. These are the sum notations, and after this, uh, After this we'll take another notations. Suppose it is small yij. This is nothing but jth unit in ith cluster in the sample. And the next thing is y bar. This y bar can also be written as y bar small n, and hence we can write it as 1 upon m into n. Summation I goes from 1 to n. Summation j goes from 1 to m yij. For all I goes from 1 to n and j goes from 1 to m. Now this again can be written as 1 upon, we can take m outside, summation j goes from 1 to m y bar I dot, where y bar I dot is nothing but 1 upon n summation I goes from 1 to n y I j. So these were the some important notations in the two stage sampling. Now moving on further, we'll derive the estimation method. How does estimation occurs? Estimation in two stage sampling. Now again I'm telling you, two stage sampling and two phase sampling. These are two different topics. One is from double sampling, which is two phase, in which first we take a large sample of n prime size, and from that we take a smaller sample of n size. And in two stage sampling, we consider the clusters. Firstly, a population consists of capital N clusters. From that we'll take small n clusters, and from that small n cluster, which is this is stage 1, and going to the stage 2, from these small n clusters we'll take out small m units from each cluster and then conduct our study. So estimation in two stage sampling can be written as, suppose we are estimating something for theta. Estimation of theta is given by E1 into E2 of theta, where this is average due to sample. This is average mean. We can also write mean if you don't understand average. Average mean due to at stage 1, and this E2 is average mean at stage 2. So this is the formula for conducting estimation in two-stage sampling. Now moving on further, if we want to find the estimation of population mean. Estimation of population mean. If we have to conduct this, then firstly we'll take estimation of y bar mn. This can be written as E1 into E2 by the formula y bar mn. Now this can be written as E1 into E2 y bar m I given I. Why are we writing this? Because our second stage depends on first stage. We know that very well. if we don't take out the clusters, we don't select the clusters first, then how are we going to take out the unit? So second stage is dependent on the first stage. So the next step would be E1. Now we have taken the units with simple random sampling without replacement, from the first stage to the second stage. So this can be written as 1 upon n summation I goes from 1 to n y bar I. This is due to simple random sampling without replacement. You can write the reason along with it. And this again, if we take the estimation of this will be nothing but 1 upon n summation I goes from 1 to n yij. This will be nothing but capital Y bar, which is our population mean. And hence we can say that this sample mean is an unbiased estimator of population mean. We are here calculating the bias. You can also write bias, or you can directly write it like this. So I'm writing the line: sample mean, which is y bar mn, is an unbiased estimator of population mean. Right? Now moving on, the formula for variance. Variance in two-stage sampling. What does it mean by variance on two-stage sampling? We'll take out the variance again. Variance of theta. This can be written as estimation of theta minus estimation of theta whole square. This can be written it like that. So we can write it as estimation of theta cap minus theta whole square. This estimation can be written as variance of theta can be written as E1 E2 theta cap minus theta whole square. This can be written it like this. Now now taking this value E2 theta cap minus theta whole square. Opening the square, we'll get E2 theta cap square plus theta square minus 2 theta theta cap. Now we'll take the E2 inside, estimation of 2 of theta cap square plus estimation of theta square minus 2 theta estimation of theta cap. E2 E2. Now we know that estimation of a constant is a constant only, so we'll write it as E2 theta cap square minus 2 theta E2 theta cap plus theta square. We have written it like this. Now we put it in the variance formula. Variance of theta is nothing but E1 into E2 theta cap square minus 2 theta E2 E2 theta cap plus theta square. This can be written now taking E1 inside. or we can first open this. Variance of theta is nothing but E1. Now E2 theta square, this E2 theta square can be written as variance of theta plus E2 theta whole square. So it can be written as variance of theta, or instead of variance we can write V2 of theta plus SE2 of theta cap whole square minus 2 theta estimation of theta cap E2 and plus theta square. Now this taking E1 inside, we'll get E1 V2 of theta plus E1 of E2 theta cap whole square minus 2 theta E1 E2 theta cap plus E1 theta square. We've taken this. So now opening the bracket, we will get E1 V2 theta. First one is this, then E1 E2 theta cap whole square minus this E1 E2 theta is E theta, then E theta is theta only, so we will get minus 2 theta square plus minus 2 E1 theta square plus E1 theta square. This will be minus E1 theta square, so we can write it as E1 V2 theta plus E1. Taking E1 common, we are left with E2 theta cap whole square minus theta square. This is nothing but the value of variance. So we are left with E1 V2 theta plus V1 E2 theta, variance of theta. This is how the variance of theta is conducted. Now the variance, we'll do the variance from the in the next lecture, because it is a very lengthy topic and we have to discuss a lot of things in that. So we'll do it in tomorrow's lecture. Till then, keep on working hard with consistency and keep on redoing the work that we are doing in the lecture videos. Keep on rewatching. If you don't understand any concept, then you can ask us on the WhatsApp channel. And I wish you all the best. And this is the time that we need to start doing the work with hard work and consistency, because there is limited time left and the syllabus is vast. So I would suggest you all to start doing the things right now. All the best. Thank you.